So for this example, we're given two forces that are acting at a point A on a hook support. They are coplanar, meaning that they both have components in the X and the Y direction, but not in the Z direction. So we can use the parallelogram law, and we can use the triangle rule to solve these. We could also break it down into the components for each in the X direction and the Y direction and combine them, which maybe we'll do in a little bit. But let's take a look at this and let's work it out. So first thing we'll do is we'll create our free body diagram. So let's represent point A. We know we have point Q. Point Q, not point Q, force Q is 125 newtons. And we are given that it is 35 degrees off of our y-axis. And then we have force P, which has a magnitude of 75 newtons. And we're given that it is 20 degrees off of the vertical axes. So given these, we know that the resultant force will be in the downward or negative y direction. And because Q has a is slightly larger than P, we can assume it'll be just a little bit to the right of the y-axis. But let's see how that works out. So the parallelogram law has us take our free body diagram and duplicate the forces on the opposite side. So we have a four-sided parallelogram. So I'm going to duplicate Q here. We've got the 125 newtons here. And then we have 75 for P. Okay, so this has created a parallelogram. It is completely symmetrical. The resultant is going to be the diagonal. Now, had I drawn this with CAD software where my scale was very, very accurate, I could scale it. I could literally draw it, make sure I had my angles inclined, make sure I had my 125 newtons and my 75 perfectly to scale, and I could scale it. For what we're going to do, let's take a look at this and we'll do some geometry. So we know we have 20 degrees off of the vertical axis to P and 35 off of the vertical axis to Q. So that gives us a total included angle here of 55 degrees. And we know that our parallelogram is completely symmetrical. So I have 55 degrees down here as well. All right, well, knowing that I have 55 degrees here and 55 degrees here, and knowing that the sum of the included angles in my parallelogram is 360 degrees, I can solve for this angle here. So if we say 360 degrees minus 2 times our 55 degrees, and then we divide that by 2, we get 360 minus 110, or 250 divided by 2. That gives us 125 degrees. So this angle in here is 125 degrees. Knowing that, now we can use the law of cosines to solve for our resultants. And you'll recall that the law of cosines basically says that the resultant squared, here, let's label this, the resultant squared equals P squared plus Q squared minus 2 times P times Q times the cosine of the angle opposite the resultant. So in this case, cosine of 125 degrees. Let's work that out. So we know R squared equals 75 newtons squared plus 125 newtons squared minus 2 and our cosine of 125 is It's a negative value, negative 0.5736. So what does that give us? It gives us r squared equals, this is 5,625 newtons squared plus 15,625 newtons squared minus 18,750 times negative 0.5736. So we have 21,250, and because I have negative or subtracting 18,750 times negative 0.5736, it's two negatives, it'll give us 10,755, which we will then add. And that tells us that R equals square root of 32,005. And that is 179 newtons. So we have the magnitude of our resultant. So 179 newtons, and let's just sketch that out. So we have our vertical line, point A. We have Q. All right, now we were given this value between Q and the vertical axes as 35 degrees. And so we also know this is vertical, this is horizontal. This angle in here must be 55 degrees because this is a right angle here. Now, we know that the resultant is not straight. We need to get the difference between the vertical axes and the resultant. So to get that value, we'll use the law of sines. And you'll recall the law of sines basically gives us, knowing the angles and the two sides, we can solve. And we're going to look at this. This is our R. So sine of 125 degrees over our resultant, which is 179 newtons, will equal this value, this angle, the sine of this angle, sine of theta, over the component, the vector opposite it, which is the 125. And we can solve for theta. So we have sine of 125. So we have 0.8192 over 179 times 125 equals sine of theta, and then theta equals 34.9 degrees. Okay, knowing that this equals 34.9 degrees, and knowing that the sum of the interior angles of my triangle is 180, I can solve for this angle. So I know that 180 minus 34.9 degrees minus our 125 degrees gives us this angle up here, and that would be 20.1 degrees. So now, what does that mean? Well, we know we have 55 degrees here. If we have 55 degrees here, and we have the angle 20.1 here, we add 20.1 to 55, and we get a direction downward of 20.1 plus 55, or 75.1 degrees downward. So our magnitude, 179 newtons, our direction, 75.1 degrees downward. So that was combination of law of cosines, triangle rule, and law of sines.